Great. So, yeah, hi, good morning, Dixon and everyone. So I just came into this a moment ago. Is there any background or anything that would be helpful for me to be aware of before we get started?
Well, we started, the first half an hour was just a kind of an overview of what SB data is and what our objectives are and how we saw it. Then we went into the cybersecurity issue, trying to help the respondents of SB data at least know what's going on. And the way I introduced it, David, was that everybody is so focused on what they're doing, understandably. It's the tree, and they're very focused on the tree, and they're trying to solve things in their own little niche, and they're sometimes unaware of what's going on around them, what I call the forest. And if they knew what was going on in the forest, that awareness and engagement would actually help them do their own tree by engaging and participating in bigger picture things. And I don't think there's any better definition of the big forest than the FIBO effort and what you're doing on a national level to try to streamline the information so that you could do data analytics on a portfolio basis across a wide range of risks. But in our case, in SB data, our risk is a solar facility and a solar loan, which would fall under FIBO, ultimately at 10,000 feet. FIBO's at 50,000 feet. And where I participate is really at ground zero when the contracts come into the system. So what I'm looking for and what I appreciate you focusing on is we've been talking about the forest versus the tree, and that's your intro to FIBO.
Great. That's a fantastic introduction. So, so I'm going to talk, and hello everyone, good morning or good afternoon, depending on where you're at. So I'm going to give you a high-level overview of what FIBO is. Dennis Wisnowski will come in on this presentation and cover the whole FIBO development and rollout process, the whole FIBO operating model and engagement process, which is fundamental to FIBO's success. So I'll cover more on the technical side of FIBO, why FIBO, what it's about, what does it look like, and you know, this is a small group, so please, if anyone has any questions, please jump in, and we'll be able to take care of those questions. So we're going to just, again, cover at a very high level, 100,000-foot view of what FIBO is, because it's a very, very extensive, wide, and deep area. We're going to cover a bit of the technology that underlies FIBO and why we're making a commitment to some of the emerging technologies to define FIBO and build FIBO. And we're going to cover a bit on, well, why is FIBO important to organizations and to regulators? How can FIBO be applied to some of the use cases? And surety bonds is certainly one of those use cases. And then Dennis is going to come in and brief us on the methodology and infrastructure and how we can engage other organizations in this collaboration effort. So first of all, then, what is FIBO? So let's go all the way back to 2008 and before, during the financial crisis, and it became quite apparent that financial institutions couldn't really effectively pinpoint the risk of their own portfolios, and national and global regulatory authorities couldn't fully understand and identify the risks, the systemic risks in the financial system. And a lot of that was due to the fact that data was relatively opaque because there was no common financial language that everybody would align on in order to curate, validate, link, harmonize the data so that when it's rolled up and aggregated, the reports really meant something. So that became crystal clear as we looked back diagnostically at what happened, and it became a whole new thrust of the regulatory community, along with the financial institutions, to come up with this new data standard that all organizations would align on, which is a very, very big task. It's a tough enough task within an organization for the various business units and silos within the organization to align on a common standard. So the first step forward was a new regulatory mandate by the Basel Committee on Banking Supervision for organizations internally to come up with data standards with the right governance, essentially having business glossaries, enterprise business glossaries, enterprise metadata, and the ability to link disparate information across all the various silos to a common data element based on common meaning. That's what we call this new regulatory driver called BCBS 239 that is a multi-year initiative, but banks must start complying with the spirit of BCBS 239 by January of 2016. The reality is that the kind of capabilities that exist conventionally do not lend themselves to really fulfilling the spirit of BCBS 239 without having some new innovation and opportunity. So the Enterprise Data Management Council, of which Wells Fargo is a member and 120 other, or it's growing, I think, maybe 150 now, organizations are members, mostly banks, mostly globally systemically important banks, but also I believe there are some insurance companies. There are some of the regulatory agencies that are members of the council. There are many vendors that are members, technology vendors that are members of the council. But by and large, the Enterprise Data Management Council is a nonprofit industry trade organization that focuses on financial industry data management, data quality, and they're very well positioned because of their broad financial industry constituency to respond to the drive by the regulatory community and the financial industry to come up with this new emerging data standard, this common language. So the council put a stake in the ground 4.5 years ago that if they were going to create this common financial data language, terminology, etc., that they would do it using a technology that would not necessarily be a technology that's been used before that is less expressive, but instead to use a technology that is more expressive that will better align with the future. So when you come up with a new data standard, you really want to be thinking forward and be good to go 5, 10, 15, 20 years out. You have to think about where is the industry moving? What is the future of data? And as the council is pretty much at the epicenter of that across the financial industry, it made a commitment, a bold commitment, that it would use this new technology, semantic web technology, which is a way of more effectively describing information and concepts. And we'll get into what that is all about in a moment. But this technology is what's used by Google, it's used by Apple's Siri, it's used by Facebook, it's used by IBM's Watson and many others. So we have very good evidence this is a good bet for the future. And in any case, that is what we've invested in. The intent is not to replace existing industry standards like XBRL, ISO, MISMO, and others, but it's to supplement them with a semantic, extended semantic meaning. And I'll get into more of that as well. So what the EDM Council did is it joined forces with another technology organization called the Object Management Group, not oh my God. And OMG is basically the technology standards group that have developed some very powerful standards that are used in data modeling called UML, and as well as many other standards for business process modeling, notation, and really many others. It's involved in a lot of future work like the Internet of Things standards and a lot of that. So the EDM Council provides the expertise from the financial industry on financial industry content. The OMG provides expertise on standardization. So that's what this relation is. And so the EDM Council, under Dennis's leadership, has formed multiple working groups that will be going through a very rigorous process of technology development to come up with a standard that we propose and submit to the OMG for their review to make sure that we did the right thing, we dotted the I's and crossed the T's so that it could be published in a format that is an international standard. So what FIBO is doing is it's building semantic domains on many of the key financial industry business domains, and we'll get into that right now. So we have these knowledge bases that we're developing because we're using this new technology called an ontology, which I'll describe very shortly. And we have these domains that we're developing all of these concepts in using semantic technology. So we have something called FIBO Foundations, which provides for a lot of building block concepts around law and organizations and people and contracts and agreements that are all high-level roots to the business of finance. And then we use those abstractions in creating some of these other fundamental and still relatively foundational building blocks for everything else in the financial industry, like business entities, legal forms, ownership and control relations between business entities. That's what's in business entities working group. We have financial business and commerce, which covers core definitions of financial instrument and product, service, account, customer, etc. Indices and indicators provides reference data for currency and country codes and rates and market rates and all of the huge set of reference data that all become prerequisite information for the other ontologies. So the green layer represents, by the way, something that has already been approved by the OMG standardization process. So we have a release of FIBO Foundations that's already been approved. The yellow represents content that is already been submitted to the OMG and is running through their review and standardization process. The pink represents what's in current ongoing development within the EDM Council and the FIBO community, such as securities, derivatives, loans, etc. We're actually going to be moving very soon debt instruments and bonds out of red into pink because we will be announcing shortly a leadership group from the financial industry that where each of the reds, which are more earlier development, legacy FIBO is what we call it, some very early but very comprehensive development of FIBO concepts we call the red layer. They're more in queue. They move into active development in the pink layer, And Dennis a little later can go into this further, and he'll talk about, you know, the commitments from the industry. But here are some of the organizations that are working with us, and the list is growing, but you could see that you have, you know, many of the globally systemically important banks, you know, many formidable players elsewhere from the industry, and you know, this is a, you know, highly collaborative effort, as you could see. Also, many of the regulatory authorities are very, very focused on FIBO. They have their eye on FIBO. The council sits on many of the task forces in the regulatory committees, from the Commodity Futures Trading Commission to the Office of Financial Research. We're heavily engaged with the European Central Bank, with the Bank of England, Financial Stability Board in the UK. This is a global effort. The FDIC, all of these organizations have had you know, many discussions and have huge interest in FIBO. So as they see the financial industry will eventually adopt FIBO as we begin to roll out from the reds into the pinks to the yellows and the greens, we'll see more broad adoption. The regulatory community will then make FIBO either a de jure standard or a de facto standard. So let's talk a bit about the technology. This is the part that excites me a lot because I am a technology person at Wells Fargo Bank. My role is to look out over the horizon and identify new and emerging technologies for Wells Fargo's adoption at some point in the future. And one of the technologies that really caught my eye 6-7 years ago was semantic web technology, because I see it as really the future of information. And as we go into this, I hope you will, you know, get some, you know, good feelings about, you know, what is in this technology that, you know, certainly leads me and many others to conclude this is directionally where the evolution of data management and information management will be moving. So the core capability within semantic web is the notion of an ontology. We could call it a knowledge base. We could call it a knowledge graph. Those are all equivalent synonyms you may hear out there in the industry. But the core thing is it's a specification of a concept. It provides new technology based on machine intelligence to define the meaning of concepts. So we have this notion of a conceptual ontology that's a very advanced schema. It's a very advanced and expressive model that not only humans can understand, but machines can understand it, because it does leverage machine intelligence in order to build this out. So it's a very powerful type of knowledge base where you could define concepts once that could be highly reused and extracted for execution by machines. So you can define, for example, what is a bond? What is a surety bond? What is a credit default swap in one place without having to write application logic? So you can query the knowledge base and pull in the concept that you could then execute and process in a program. You do not then need to write all this additional logic that is written today over and over and over again in many application programs within an organization. So ultimately, we see a reduction of software costs, a reduction of quality assurance testing, because it's already done in the creation and the vetting and the testing of the ontology, so that we could take a lot of shortcuts in the future. So we'll have much more faster time to market to deliver capabilities, because a lot of it will be simply retrievable from the knowledge base and linked and executed. We also get the benefit of tying it to machine intelligence under the covers, in order to draw some new inferences and insights by leveraging machine intelligence. It also hooks in very well to machine learning. But let's cover what is this thing we call an ontology? How does it describe the meaning of concepts? So we'll take a basic concept that I'll walk through, and this is the concept of corporate ownership. So as I'm going through this, think about your own particular area of expertise, the business information that you currently are engaged with, and how you would benefit from having a lot of knowledge represented in a knowledge base. And the challenge is, of course, how do we do this? So everything in semantic web technology, the ontology, is linguistically aligned with how we think and speak. It drives down to a basic grammar, a basic sentence that we know from grammar is subdivided into subject, predicates, and objects, the elementary structure of a sentence. So we could make a statement: some corporation owns some other corporation, subject, predicate, object. The semantic web, the ontology, positions us, by the way, to consume unstructured content, text, documents, communications, into a structured form. It provides a very good format for it because, again, it is based on a sentence structure itself. But this is how we can begin to weave in concepts. So we can introduce other concepts. Let's say we have this notion of owns, which we'll call a predicate. We can introduce another refinement of owns that will say owns more than 50% voting shares. So we'll make a statement: a corporation owns more than 50% voting shares of another corporation, by creating this new predicate or verb that we could tie back to owns, and we could say that owns more than 50% voting shares is a kind of owns. It's a subproperty or a subclass of owns. So if we say that Corporation A owns more than 50% voting shares of Corporation B, because of these relationships, we can infer, therefore, Corporation A also owns Corporation B. We can then weave in other types of concepts. In this case, owns more than 50% voting shares has a polar opposite we could call is majority owned by. So if Corporation A owns more than 50% voting shares of Corporation B, and we could state that owns more than 50% voting shares is the inverse or polar opposite of is majority owned by, we could draw an inference that Corporation B, therefore, is majority owned by Corporation A. We could assert facts into these knowledge bases where we could say that Global Bank is a type of corporation. Again, Global Bank is the subject, type is the predicate, corporation is the object. London Bank is a type of corporation. So now we could then assert that Global Bank, a type of corporation, owns more than 50% voting shares of London Bank, another type of corporation. Therefore, London Bank, we can infer, is majority owned by Global Bank, and then we could further infer through other rules that we've defined in the ontology that Global Bank most likely plays the role of a holding company, and London Bank will therefore most likely play the role of a subsidiary of Global Bank. So once you define a certain subset of relations and facts and rules, you can infer a superset of relations and facts and rules, which makes this very powerful. So this is sort of just a very little snapshot of some of the capabilities available to us using machine intelligence and ontologies, where we can define these types of relationships. One more example: everything in semantic web is a web. It's a web of things. Everything also has a web address. Everything is accessible over the internet. So this becomes a new standard for the internet, and it's actually been standardized by the group that produces all the web languages, the W3C. And every piece of information also is linked to every other piece of information in a little mini network or a web or a graph, we call it. And we could read this. So we could say swap 1001, we're looking at an example of a derivative that we could say has leg 1, which has a notional value of 10 million, which has a currency of US dollars, and so on and so forth. So you could just walk through this graph of objects that are related to other objects through meaningful relations, again, subject, predicate, object, and you could make all these statements. So a leg 1 has a party relationship to an object called the legal entity identifier, which has a certain value, which identifies another object that we've defined as a business entity whose identity is London Bank. So we could take this graph of information and we could link it into the ontology where we can create the definition of a financial instrument, which we call a fixed float interest rate swap, which can be synonymous with another name called a vanilla interest rate swap, but they will all be tied together because they are different labels or tags of the same meaning. So we can introduce a human-facing definition, but then we introduce the machine-facing definition for a vanilla interest rate swap or a fixed float interest rate swap, which looks like this, which basically is realized in the ontology by drawing certain inferences. So elsewhere in the ontology, we could say that any object that is a leg that is tied to any object that is an indexed rate, in this case LIBOR, using the relationship leg 1 has index LIBOR. Any of those two objects that follow a rule where the indexed value is some kind of floating rate will infer that this leg is a floating rate leg, will infer that any leg that's associated with a fixed rate value, we'll call it a fixed rate leg. And based on the rule that we've defined in the ontology, any swap contract that has one leg that's fixed and one leg that's floating, we're going to infer to be a fixed float interest rate swap, which we could infer to be an interest rate swap, which is a swap, which is a derivative, which is a financial instrument, which is a written contract, which is a contract, which is a kind of an agreement. So we could infer all the way up the stack, and you could see how things get interrelated to other things. We could also draw inferences where we might ask the question, which business entity is trading with which business entity? And because these are already linked in a graph, we can define a rule in an ontology that says that any node or business entity that's linked through its relationships of being parties to a swap contract, we'll say they're trading with each other. So this is actually a way where we could achieve a couple of use cases. First of all, we use the knowledge in the ontology to validate and curate information. So let's say that the publisher of this graph might have said that this is a basis swap or a float-float swap. Well, when we look at the actual information using this machine-based reasoning that comes with the technology, we would say, oh, wait a minute, you are really a fixed float swap because one leg is fixed. You're telling us you're a float-float swap, which implies both legs are floating, but in reality, that's not true. So we're going to create an inconsistency. We'll create a red flag because something is off, something is inconsistent. So we could use these structures with machine-based reasoning that will come back and say inconsistency, or it'll say you've got it right, you're consistent. We basically have a validation logic built in that will curate and validate content. So if And this is very important from a regulatory point of view because we want to have highly curated, high-quality information that's been validated. And once we have a high level of confidence that the instrument is what the publisher said it is, then when we aggregate that information with hundreds and thousands and millions of other records that have gone through the same curation process, we could say that the sum total, the result of that aggregation, is accurate, as opposed to what we've had conventionally without all of this capability built into it. We've had to introduce a dramatically higher and more costly amount of governance to prove accuracy. So that's a major use case. I'll cover that in a little bit more later. The other thing is that we get the benefit of linking information because we not only have this structure as a graph, but it links to other graph structures and so on and so forth that we could traverse using very new powerful query languages. And this we don't have to convert our technology to use this capability. For example, we can easily map information from an XML payload to a semantic structure. So XML is mappable to this. Relational database is mappable over to these structures so that organizations do not have to do any kind of massive big bang conversions into this format in order to leverage some of these capabilities. So just here comparatively, we can compare this to an XML schema and an XML message. This is an example of a XML message for derivatives called FPML. So it's for financial product markup language. It's used for derivative trade confirmations, but it could be equally for loans using Nismo. And of course, it could be equally for financial reporting from XBRL. We could transition and map from the left to the right. And once we get it into a semantic form, we can then apply many of the rules of the ontology. It's now again in that single version of the truth, one form, one standard that people in the industry agree upon. And you don't have to write an application program as we do with a XML schema. The understanding of the content requires an application program typically to make use of it. Not that we get rid of application programming. That's not going to happen anytime soon, even with ontologies, but it gives us a couple of steps forward of benefit of not having to rewrite some of the logic that we've now standardized in one common place. So why should this be important to your firm, to regulators? So there are a lot of benefits. FIBO and semantics using these ontologies provides an underlying scaffold by which we could, first of all, identify the meaning of concepts. What is a surety bond? It could be defined in an ontology and queried. It also can support that initiative I talked about earlier from the regulatory community called BCBS 239. And the technology positions us to have a financial Rosetta Stone, which I'll cover in a moment, but you can have that same meaning in many different formats, and an ontology can unify and harmonize all those different formats that mean the same thing. And it could provide benefit for other initiatives like legal entity identifier, legal entity ownership and control relations. It could provide other common models for regulatory compliance and reporting, as well as because it's already a graph and a network of related concepts and related data all linked together, it positions us to much more efficiently see the associations and the relationships between data to use for risk intelligence. So how can this be applied? So let me go back. Conventionally, most business glossaries are, we'll call, two-dimensional. There's a label or a term and a definition. We might find some ways to see how some of these fit in a hierarchy, but it's very limited, so we'll call it two-dimensional. But in reality, information is multidimensional or n-dimensional. So while before we looked at the concept of an agreement with a definition, a contract is a kind of an agreement, a mutual contractual agreement is a kind of a contract, and so on and so forth. With this technology, we can create a very highly multidimensional view of information. So I'll show you a snippet of it here. So this is a capture of a screenshot where if this were available, and I could probably show you this live if we had time, you could search for a concept against the knowledge base. So here's contract. Contract is a kind of an agreement. That's what we mean by broader term. Agreement is broader than a contract. And what we mean by narrower terms are concepts that we would call subclasses of a contract. So a written contract is a kind of a contract. A verbal contract is kind of a contract. So we could tie these concepts together. Contracts have effective dates. They confer obligations. They have parties to the contract. And each of these concepts becomes an animated object in the knowledge base. And you could click on hyperlinks. So if I wanted to find out what a party is in the definition, I could click on that and it'll jump me over to the linkable concepts about party. Or in this particular tool, each of these little bubbles or circles are clickable. So I could click into contract or written contract, and it's going to open up all the concepts that are kinds of written contracts. Likewise, I could query the graph, the knowledge base, and ask what is the structure of a surety bond? What does it look like? What are all of its related parts of information? In this example in front of you, I've asked for what is a fixed float interest rate swap contract, and this is something that we queried the database and it pulled this structure back because a contract has terms, it has other types of structures that you could see here. There are parties to the contract, there are notional values, currencies, and interest rates. So you can look at the knowledge base, pull this structure back, and you could think of it equivalently from, a lot of this came out of biotechnology, so they would query the knowledge base to give them a visual diagram of a protein structure. Well, in finance, it's no different. We have all of these very complex structures that we can look at as molecules or proteins or genomes of information and pull it all together. So these sets of additional relations suggest that this is why I'm proposing to you that this is the next step in the evolution of information management because of this powerful capability against the database. And then you could extend it. So you could then, this picture reflects an extension of all the concepts that are in the FIBO ontology. Any company can extend it with its own unique additional DNA or properties. And so you get a high amount of reuse across the industry, which gives us that common language. So if everyone starts to make use of FIBO across the industry, then we have common terminology, common meaning, common rules. So the level of reuse now begins to really take off. So now, in terms of the Rosetta Stone capability, if you look at these constructs here on the screen, they all mean the same. Global Bank owns more than 50% voting shares of London Bank is a sentence. We'll call that unstructured content. You could get the same relative meaning in an Excel spreadsheet, in a relational database, and so on and so forth. Having an ontology allows us to leverage other technologies that do mappings between all of the different disparate protocols that mean the same thing into a common ontology. So we went over this diagram a little earlier. This provides the unifying framework conceptually by which all this other information can be basically translated and mapped and harmonized into a common format that we could query. So from the point of view of surety bonds, where there are many different silos in an organization that represents the surety bond in a relational database, or someone else represents it in an Excel spreadsheet, this technology can harmonize it all into a common format. And you can do this for all kinds of information. So everything, again, in semantic web is a web of related information. It's a graph of information. And this is an example of a screenshot of another query against the semantic database that looks to see all the relationships between banks that are trading derivatives with one another. And it runs algorithms to identify systemic risk, because there are all kinds of algorithms that we call graph analytics that identify who in the network of relations is the most influential, who is the most central. Very similar to social network analysis. We can apply these technologies to create risk exposures. So in this example, Wall Street Bank is the largest icon, so it represents the largest aggregate amount of money exposed for derivatives. Trading with Big Bank, which is another large icon, so there's a lot more money there. The flow of funds between the two is larger, so we could show that proportionately. And the numbers inside these represents a measure of centrality. And so you could see visually the trading network, and you could see with these numbers that the higher up the number, ultimately to 1, the greater the impact upon the network in case of failure, because of the fact that Wall Street is the most central and influential. It has the most trading partners who have the most trading partners. If Wall Street Bank failed, it would create a greater cascading impact upon the network than, let's say, if Atlas Bank failed, which has a much lower number. So we can begin to use this technology for systemic risk and for many other risk-related types of use cases. So I'm almost done, and I'm going to turn over to Dennis in a moment. But now, jumping over to XBRL, and very similar to my prior slide, XBRL as an XML schema would be the transport protocol for surety bonds. But if we begin to create a surety bond ontology, leverage a surety bond ontology in FIBO, which would be basically linked into a bonds ontology, which would be linked into a debt instruments ontology, which would be linked into all of the other FIBO ontologies that link to business entities, that ultimately will link to risk and other regulatory ontologies that we'll be developing. We get that benefit of associating concepts and linking concepts. So if we have all these different organizations or silos that leverage a common ontology, and we can say we've validated the information through the ontology, it's all correct. We then put it out on the transport pipeline in an XBRL format, so that the receiver of that XBRL format then maps the content back to the ontology to further validate it and to link it into all other related information domains, we get a very robust process. So that was pretty much it. I want to turn this over now to Dennis to pick up on the methodology. And Dennis, you want to take control or ask me to drive, whatever you would like.
David, this is Dixon Wright. Thank you very much for that. That was, I'm sure, for the IT folks, quite the candy.
You guys can all see my screen?
Yes.
I'm going to talk about what my role has been. David, his role as the CEO, basically, of the ontology itself is to figure out how we go forward in terms of various data stores that come out of or that are really the 30 FIBO ontologies that I showed you in that horse blanket chart earlier, the reds, pinks, yellows, and greens. My job is to form the teams that can build FIBO and work together. So to do that, we have a continuous integration methodology that's very much based upon state-of-the-art tools. We use GitHub for a repository. So all of these 30 FIBOs, the legacy, the development, the process, and OMG are sitting in GitHub. Our teams look at these ontologies, they extract from them the part that they want, or any one of these 30, I'll show you in a moment, the ones that are in play right now, any one of these 30 ontologies, and they create the data stores that are then automatically executed through Pellet and Hermit, which is open source software to do sanity checks or hygiene checks in these RDFL data stores. Ontologies, and actually General Alexander said it earlier in the Cyber Command work, are two parts. One part is people readable, and those are, in our case, UML files, Universal Modeling Language, and machine readable, that's the RDF file. That underneath that is actually XML, which will make a connection with XBRL. So these Jenkins jobs are automatically spawned when a data store presenting a FIBO ontology is put into the pink branch of GitHub. When there's an issue, we use Jira on the left side here, talking what that issue is, and then our team gets together, our FIBO content team gets together and resolves that issue. All of our the content, every single conversation is recorded by Atlassian source tree, by Atlassian wikis. So we keep the wiki to manage the people. We keep Jira and Jenkins to manage the content. All of that content of all types is on GitHub. So we have collaboration, governance, quality assurance, and standardization. Those are the four components of keeping this going always in the same direction. David showed you I call it a horse blanket, I'm going to go chart that is all of the FIBOs. Here you can see how they move from the red to pink to yellow to green. And the first one was FIBO Foundations. That's at the very top. Let me make this go backwards. That's at the very top. And that was our first FIBO. That was followed by FIBO PE business entities. David's in charge of that one. All of these FIBO teams are led by a banker or someone in the financial industry. For example, securities and equities. This is being led by Bloomberg, and they also have an ontology attached to. In this case, it's Alicia Kendall. FIBO Loans is Wells Fargo, and their ontologist is Mike Ushold. Business Entities is Wells Fargo again, with their ontologist being Dean Allemang, who wrote one of the very first books about ontology. So these are the 6 that are in play right now through OMG. The 7th one is derivatives, which is now a proof of concept, and then we also will be having FIBO SCOS, which will be the FIBO vocabulary. That will be not a RDF-OWL ontology, but will enable other people who aren't quite as advanced as we are to take advantage of FIBO. Also, schema.org will enable web developers to attach their data stores to FIBO to answer questions that help them make decisions instantly for themselves or connect their data stores to FIBO without, again, being sophisticated ontologists. So this roadmap has all of these content teams working simultaneously, all going in the same direction, and using our methodology we call the FIBO build, test, deploy, maintain. This goes on and on and on because, by definition, these are linked data stores, and when you start to build a FIBO, you go back into the red legacy FIBO, extract from that what you think is important, attach what you want to build to what's already been developed. So you would go to FIBO Foundations, you would go to Indices and Indicators, you would go to Financial Business and Commerce. Those are existing ontologies. You would attach to them what they have, and you would build yours in addition to that so that when it goes into the overall RDF triple store and overall UML model, all of these pieces are tied together, all according to our standard. So how do we do that? On the outside of this, we have the FIBO leadership team, David and I, and the people who are on each one of these FIBO content teams. That's what's shown here. And they work in accordance with the FIBO process team, which says, and there's a 25-page FIBO build, test, deploy, maintain document that shows how all these components work together, as I said a moment ago, GitHub, Jenkins, Jira, the wiki. And so the goal is to graduate these FIBOs from the red to the pink to the yellow to green. The testing is really important. So FIBO content team pulls from the red what they want to create as an ontology. That's will be bonds, as David said. You can't say who it is yet, but that'll be that's a bank that's already agreed to do it. And they graduate from the red to the yellow to the pink to the green. The FIBO Fended team provides the tools to test the ontologies. So it's important that these ontologies not be theoretical in nature only. They begin that way, but they can be tested against real non-person identifying information data. So it's fake real data that the banks provide to see that these ontologies really work. So that's how this happens. In addition to this linear process, we have FIBO proof of concept teams, one of which is State Street Bank, one of which was Wells Fargo doing Greg W. And they can pick any FIBO in any state, and they can see what happens when they try to aggregate their data using what FIBO says their data means. On the bottom here, you can see that our files are all in OWL. We use Protege because Protege is open source, and also UML because, again, I said people-facing, that's UML, machine-facing, and that's OWL, RDF OWL, that's Protege. And then there's supporting files that are the more additional metadata, the how to use these ontologies and so forth. This is a process we've had established for about 18 months now. We bring new teams in all the time. They don't have to start from scratch. They jump in, they read the simple 25-page document. They're given access to GitHub, Jenkins, and Jira, and they're on their way cooperating with the other teams. So how could you work with us? Here are the teams that I've represented, and these teams are the leadership team. Anybody who leads a proof of concept team is on the leadership team. We have several always working at once. Proof of concept teams, the task forces getting our product through the OMG, teams that want to implement operational technologies, a process team, and vendor teams. Every team meets at least once a week. There's a regular schedule. The schedule of what these teams, how these teams meet, is on the EDM Council website. Everything is in the open except for the actual RDF OWL pink ontologies. There, people need to be part of EDMC. And you can see the legacy ontologies on the council by logging in, but without paying anything. You can see the yellow and the green on the OMG websites. That's public. But to play and participate daily in the real ontology to use yourself, there's a requirement to be an EDMC member. There are 150 council members right now. The number is growing. In August, IBM and Oracle both came back after being gone for about a year. And there are many, many other kinds of companies that participate, literally the whole financial industry around the world. And that concludes our presentation.
Dennis, thank you very much. This is Dixon Wright. Michelle Savage has joined, and I know, Michelle, you've had a chance to take a look at the FIBO presentation. Would you do us the favor of sharing XBRL, the work that you've been doing there for the financial reporting, but also touch base, if you would, on the meeting recently in Chicago and the working group that's going on between the Surety Association and XBRL?
Sure, Dixon. Thanks for inviting me today. I'm going to be able to address, it's going to give a little bit of an overview of XBRL. I'll talk about XBRL specifically in the Data Act, and I don't have a presentation to show, so I'm just going to be kind of talking through this. And then I was going to talk a little bit about XBRL in solar data. I mean, at this point, the Surety project, I'm not really ready to address that today, Dixon.
Well, that's fine. This is
okay. Okay, so just to give you a little bit of background on XBRL, and some of this was touched on earlier, and I apologize, I missed much of what came before due to prior meeting setup, but so if I'm repeating some things here, just bear with me on this. But basically, XBRL is a global open technology standard. It's used today to report business information in a computer-readable format, and it's primarily used for financial data. It's based on the XML standard, and XML, of course, is used to tag reported values with context. What XBRL does is it expands on XML by using consistent methods to report some of the context that XML is able to report. So, as an example, XBRL defines consistent methods to report elements, units, decimals, reporting periods, tables, labels, and entities. And it can also be used to define relationships between different parts of those disclosures. So, for example, whether a set of numbers adds up to a total, like a calculation, or the sequence of line items within a financial statement, the hierarchy of terms or the presentation, those are also defined in XBRL so that the end user of that XBRL file can understand it much more easily. So XBRL basically permits business data to be defined in a standardized way so it can be read, it can be processed, it can be analyzed by different computer systems consistently. And what that enables is comparability from one reporting entity to another. So XBRL enables the transfer of business reporting information between computer systems without losing any fidelity in the information. And it also does it at a significantly lower cost. And therefore, it enhances that comparison of business reporting data. So the standardization eliminates the cost of manually processing the data or using proprietary products that typically lock data into incompatible formats. It is a globally accepted standard, and so it enables the creation of universal kind of XBRL-enabled software. And that software can be used to create the data, to manipulate the data, to extract the data, and ultimately to analyze the data. And because it's computer readable, it does it in a very timely, efficient manner, and therefore it reduces costs for both the preparer of the data as well as the consumer. In the U.S., XBRL was initially conceived of. The whole idea came out in 1999, but it's widely used around the world today for government reporting, for public company reporting, for private company reporting. And in the U.S., it's used today by bank institutions and by public companies to report financial data. And it's used by data intermediaries and investors to analyze that data. So every public company in the United States today uses XBRL to report financial data to the SEC. So they report in XBRL every quarter. And they've been doing that since the final rule went into place, or was enacted, went into place in 2007. So the first data reported is from about 2009. And that program was phased in over time, so larger companies, which got the requirement first, have a larger history of data than smaller companies, but every public company was reporting all of their data by 2011. So there's a fair amount of data available today. The other big implementation in the U.S., which actually started before the SEC program, was with the FFIEC, the Federal Financial Institutions Examination Council. And that covers the FDIC, who's actually spearheading the program, and under that is also the Federal Reserve, I believe the Office of the Controller, and a number of other regulators on the financial side. So with the FDIC program, or the FFIEC program, every bank institution in the U.S. is required to report their financial data in XBRL format. And that program is a little bit different than the SEC program in that there are kind of a handful of software companies that provide interfaces that the banks actually input their data into the interface, and then it's transformed into XBRL format. So for bank institutions, when this program went into place, which I think was around 2005, they were using a software program to basically input the data. They didn't have to know a whole lot about XBRL. With the SEC program, on the other hand, companies are actually, tagging or, creating their XBRL themselves, and they're doing it a variety of different ways. But so they're required to really know much more about it. And the SEC program, because it relies on the U.S. GAAP standard, is much more complex because there's a fair amount of flexibility in U.S. GAAP reporting, which means that companies can report lots of different ways, and so they really need to understand what they're doing with their XBRL. Also in the U.S., there was an act passed in 2014. It was signed into law in 2014 called the Data Act, the Digital Accountability and Transparency Act, which requires U.S. Treasury and OMB, the Office of Management and Budget, to adopt common data elements for financial and payment information that are required to be reported by federal agencies and by entities receiving federal funds. So essentially, the data standards that Treasury and OMB developed were required to incorporate a widely accepted, non-proprietary, searchable, platform-independent, computer-readable format. And they had to include unique identifiers for federal awards and entities receiving federal awards that can be consistently applied government-wide. XBRL US, my organization, was actually involved in the early drafting of this legislation, and it essentially was written in such a way that it really speaks to XBRL. And ultimately, XBRL has been, termed the data standard that will be used for Data Act reporting. So through the Act, Treasury and OMB are establishing these government-wide financial data standards that are expected to increase the availability, the accuracy, and the usefulness of federal spending information. Implementation of the Data Act must be complete by 2017. And it essentially requires federal agencies to report all spending in structured data format. There is also a pilot program that is going to begin, and it's designed to determine the benefits of requiring government contractors to also report in a structured data format. So therefore, contractors today are not required to file in structured format, per the Data Act, but it's likely that they will at some point in the future. So the Data Act was really put in place, in response to demands for better consistency, accuracy, and timeliness. There was clear evidence of shortfalls in the current state of reporting by agencies, and that was outlined in a study put together by the Government Accountability Office in June of 2014. And that study found that government awards data reported in USAspending.gov, which is the big repository for this information, often had data that was missing, that was reported improperly, or that was inconsistent when it was compared with agency data. So the structured data requirement in the Data Act is clearly evidence that Congress sees the value of standards. Then XBRL is also under consideration in a number of other reporting areas. Surety bond reporting is one that was mentioned, and there is a project that's being developed right now. It's also being considered for solar energy reporting. And just to get by way of a little bit of background, XBRL is a data standard that's used in conjunction with what you might call an information or a business standard. So these business standards are kind of harmonized with XBRL. And some examples of standards that have been harmonized today include US GAAP. We talked about the US GAAP taxonomy for US financial statement reporting. UK GAAP is another one for UK financial statement reporting. ISO 20022 is a standard that was developed for the reporting of corporate actions events, which are essentially events that happen in the life of a public company, like a merger or a stock split or a dividend announcement. We have harmonized the ISO 20022 standard with XBRL to create a corporate actions taxonomy. So that essentially it's layering the two taxonomies on top of each other so that ultimately we're able to report in a consistent fashion using terms that are accepted and widely used by industry. XBRL is most commonly used, and it was developed specifically for use with financial statement data, but it can easily accommodate other types of business data as well. And that's where we started looking at the solar project. So today there are lots of reporting needs in the solar energy supply chain, which include financial information and other types of business data. So there are standards out there like SunSpec, like BEADS and IEP, that have been developed to provide a consistent method for creators and consumers of solar data to define the data that they're collecting, reporting, and analyzing. We believe that harmonizing XBRL with these solar energy standards will ultimately create a standard that enables us and all the members of the solar energy reporting supply chain to create and use computer-readable data. So the computer readability will come about through the XBRL standard, and it'll be aligned with the definition and the element attributes that have already been agreed upon by the marketplace, and that's through the solar industry standards. So industry agreement is really critical to rapid adoption of the standard, and the computer readability is critical for the automation. And the automation is really what's going to help improve the timeliness and the accuracy and ultimately reduce costs in that process. So the plan that we've been looking at is to build a solar data XBRL taxonomy. And when you look at some of the elements, and the whole project has not been fully scoped at this point, but a large percentage of the data elements that are needed for solar energy reporting are financial in nature. And the US GAAP taxonomy, which was developed and finalized actually in 2009, contains about 15,000 financial elements. Those elements, and the taxonomy was commissioned by the SEC. It was built by my organization, XBRL US, and today it contains about 15,000 financial elements. They cover all income statement, balance sheet, and cash flow statement data, as well as all the values that are embedded in a company's footnotes. And it's particularly large because it also covers lots of industry-specific line items that the different industries need to report to really articulate the position of the company. So that taxonomy, which was the initial draft, was finalized in 2008, and it's now supported and maintained by the Financial Accounting Standards Board, by the FASB. They publish a new release every year, and typically what the SEC does is they take that release, they approve it, and then they allow companies to use the current release and then the prior year release of the taxonomy. All taxonomies go out for a public review process for 60 days, during which anyone can weigh in on that taxonomy and review the concepts, and we take a close look at it as well. And then it's finalized and published. The solar energy project team will leverage a large subset of the data items that are available in the US GAAP taxonomy, and that will serve as a starting point for the solar data taxonomy. What we're proposing is that we would take the data elements needed for solar reporting, match them up against what's already available in the US GAAP taxonomy, make sure that the definitions are the same, and then look for elements that are not available in the US GAAP taxonomy. Identify those elements and create them, determining the definition, the labels, the units, other metadata that is needed to accurately describe those facts that need to be reported to that element. And the resulting solar data taxonomy will consist of a subset of the US GAAP elements combined with those new solar-specific elements based on solar energy standards, including ones like SunSpec and BEADS and IEP, the ones we mentioned before. But the underlying data standard, or the mechanism to convey that information, will be XBRL. Back several years ago, XBRL US also developed a prototype taxonomy for mortgage-backed securities, and it really looked at developing some of the underlying terms that were needed, and that could also be leveraged to report on financing situations within the solar industries. So those could be combined to this taxonomy as well. So, we believe that taking the solar data standards and combining them with XBRL ultimately will create a standard that transforms solar energy information into consistent, comparable, computer-readable data, and it'll rely on definitions that have been agreed upon by industry stakeholders, and that obviously is critical to ultimately getting this thing adopted. So just to conclude, XBRL is really the industry standard for financial information reporting. It's used around the world for reporting by government, by private companies, by public companies, as well as securities reporting. And it accommodates reported values, numbers, as well as reported text. So it has a level of flexibility within a structure that enables consistent, comparable reporting. So, Dixon, I think those are the key points that I was going to make in my talk today. I don't know if anybody has questions or...
Well, first off, I want to thank you very much for taking your time, and you and David and Dennis. As I shared at the very beginning, 8:30, 3 hours ago, a lot of the people on SB Data are really focused on individual aspects, and the goal of this call was not only to have the respondents see the bigger picture and to see what other opportunities are out there for them to plug into, but to try to help everybody put together the best SB Data response as possible, because they have a broader perspective. So I really, really appreciate everybody for doing that. And I do open it up for any questions if anybody has. Most of the players are on SB Data, have already had a chance to meet with XBRL and to talk about it because it's part of their proposals. But if there's questions, now's the time.
This is Dennis. I have a question for Michelle. XBRL, as you said, has been around since about 1999 and is in following. In addition, there are many other standards in the financial community that support particular constituencies. And one of the things, and the lower level of the RDFI, the semantic web stack, is also XML. So we view these XMLs as various dialects that are important, but they're a dialect of that particular industry. And one of the things we see that we're interested in your opinion of, Michelle, is that the JSON LD is perhaps a way of bringing all of these dialects together under a semantic web structure that would enable the efficiency of understanding the meaning of the terms, which many of them, the definitions are common, but the word is not, that says what you're talking about. So you guys looked at this, at JSON LD, and how it might impact future direction of yours and all the other XML transport layer standards?
To be honest, I would really need to defer to my more technical colleagues on a question like that, and I'd be happy to maybe have a follow-up call with you so that we can talk about that further. But that's not really something that I could weigh in on myself personally. So I'd have to defer to our CEO, Campbell Pride. And I don't know if you know Campbell, or even potentially John Turner.
I know Campbell. I met him at an open data conference in Washington a few months ago. Yes.
Okay.
I'm happy to talk with him more.
Yeah, well, maybe it may make sense for us to schedule a separate call to discuss that further. That's not something that I personally can weigh in on.
Thank you.
Right, well, we were scheduled to end at 11:30.
Dixon, David here quickly. Any other next steps now, following this discussion and briefing that you see as sort of a logical follow-up of where we are now?
Yes, I can answer that very succinctly. The DOE on the SB data is going to be engaging in all the respondents here in some time in the future. I spoke with them at the Solar Power International Conference. They are still thinking maybe November or December. But when they do, the SB data respondents will start to put together a strategy working group. And that strategy working group, which is Area A, is going to be working with Area B and C, which is implementation and sustainability. So the SB data is going to embark on this journey as soon as the DOE releases the proposal and direction.
Okay. So in between then and now, we'll certainly keep in touch. We'll give you some more updates from the FIBO end as we formalize and launch our debt instruments work, and that's where we'll have a technical team that will come together to focus on bonds, and we certainly want to keep in sync with you about surety bonds and perhaps prototype a surety bond ontology.
Well, and I might add that our work in the industry for surety is not dependent on SB data. We are looking to write surety bonds. These projects are ongoing now, so we are not waiting for SB data. We're going to be moving on ahead regardless. But I think SB data provides a great platform for bringing consensus, and I hope that the work we do between now and then helps add to that consensus and helps add to that knowledge base that makes it easier for SB data to really be successful.
Yep. Okay, thanks, Dixon, and thank you for engaging us.
And everybody, if you want more information, the website still is there. We've posted the deck pages for the FIBO presentation, the links to the article that Al Berkeley written, as well as links to everybody as far as being able to connect with them. So I thank you all for joining the call, and let's hope that